My name is Salomon. I am a member of the Rados Gateway team. For the last 3 years, we are developing the S3select. This talk is mainly an introduction to S3select. I'm going to talk about the concept. I will explain what it is, why do we need that, how does it work, and please feel free to ask any question at any point of the talk. It's about sharing knowledge. Okay, so let's start. In July 2020, S3select was introduced to the Ceph upstream. AWS announced that about 2 years before that, in 2018. S3select is another S3 request. It enables the client to push down an SQL statement into the Ceph storage. The SQL that we are using there is according to AWS spec. The S3select is a new S3 capability designed to pull out only the data that you need from the object. It can dramatically improve the performance and reduce the cost of application that needs to access data in S3. Okay, why do we need that? What is it good for? So we need to recall that S3select is actually implement a push down paradigm, and the push down paradigm is about moving or pushing the operation close to the data, in contrary to what is commonly done, which means moving the data close to the place of operation. Push down does not consume memory, while caching does consume memory. In a big data ecosystem, it makes a big difference. Upon using cache paradigm, the flow is about what data to keep in cache and what data should invalidate. Upon using push down, the flow is about what operation should push down and how to use the return result. So for one example, let's say in order to execute select sum of X from some object where A and B bigger than C, it needs to fetch the entire object to the client side, and only then execute the operation with some analytic application. With push down, our S3select, the entire operation is executed on the server side, and only the result itself returned to the client side. So an SQL query that needs to operate on CSV or JSON object that contains many columns and rows, but needs only a very small portion of it, a few columns or small percentage of the rows, will return only a small amount of data. It means less operations of serialization or deserialization. And also it should note that pushing down operations close to data, it's not an easy thing to do. The storage is usually fragmented and broken into random pieces. It makes it difficult to execute single query on top of many random pieces, and moreover, the type of these objects could be a binary in some cases. What is S3select capable of? S3select does not turn our S3 storage into a database, but it does improve greatly the efficiency of SQL processing. It should be noted that SQL dialect provided by the S3select is only for read. It's only the select statement. There is no notion of schema or table, and the object being read should enable tabular operation. S3select system is embedded into the get object module, what makes it highly efficient for push down operation. So upon SQL query being pushed down, the object is fetched, and each fragment of the object is processed by the S3select module. Since the S3select is embedded into the S3 system, there are no redundant copies of bytes, and the object is processed immediately, and the results sent back to the client. Moreover, S3select system is capable of processing CSV, JSON, and also Parquet. The same engine, by the way, is processing all of these types. 1 second. Okay. Why using SQL? So maybe the question should be that should be asked is what is needed for the machine learning? SQL is needed for the machine learning. In practice, this is the language that is for querying data. It should be noted that SQL is a domain-specific language. More than 40 years, it was designed initially for manipulating data. In machine learning workflow, the data is the main thing, is the source. So the more relevant and accurate your data is, the better your modeling and pattern detection will be. You should keep in mind also that data must be formatted so that it can be used by machine learning algorithm for improved pattern detection. All of this makes the SQL the starting point for machine learning. Adding the capability to read and process different and common data sources such as CSV, JSON, and Parquet makes the S3select a powerful tool for machine learning. So why S3select is useful for S3 storage? Okay, so as you probably know, the S3 storage is a reliable, efficient, and relatively cheap storage, and already contains trillions of objects. It contains many CSV, JSON, and Parquet objects. And these objects contain huge amount of data to analyze. And ATL may convert these objects into Parquet and then run queries on these converted objects. The Parquet is, by the way, is very efficient format, but converting each of these objects to Parquet, it comes with a very expensive price. Getting all of these objects downloaded is a lot of network. So S3select engine that reside on the in our storage, it can do this job for many use cases. It saves time and also resources. CSV and JSON that reside on S3 storage consider as cold data. And upon using S3select, this cold data can be accessed efficiently. Query huge and semi-structured, such as CSV and JSON, not using S3select is very expensive. It consumes a lot of network and also consumes CPU for serialization and deserialization. Our goal is to turn the safe object storage more attractive for analytical operations, not just for storing data. Okay, some points related to the software design that should be noted here. The engine itself is header-only code, no libraries, except for one exception. The Apache Arrow Parquet is a library. S3select is a single-threaded function. It reuses memory for its operation. There is no intensive allocation or deallocation. The memory that is consumed by the engine is enough for the row being processed. For that reason, the engine is able to process any size object. Readers of the different data types are decoupled from SQL engine. So future readers for other data types, such as ORC, for one example, can reuse the engine code. It's also a standalone application. The same S3select engine can be used from the command line as a shell command. And it can process the different data types, the CSV, JSON, or Parquet. In coming slides, I will explain about the different flow of each data type and the differences between the data source types. We have the CSV, the JSON, and the Parquet. We start with the CSV. The CSV is the most simple format. It is not supporting. It's not supporting data types, and as trivial. Meaning, when I say it's not supporting data types, it means it only supports string, of course. You need to cast it into your some native type like integer or float or something like that. And as a trivial schema support, almost every log file could become a CSV object. JSON is more sophisticated format. It supports data types and also schema. So upon processing a query, both formats should read and scan completely the entire object. JSON and CSV are text object and must be read completely. On the other hand, Parquet is a highly advanced object. It contains enough metadata that enables the user to access only the data needed by the query processing. That means by using Parquet object, it's not just saving network bandwidth, it also saves a lot of IOPS on the server side. Okay, so let's talk about the flow itself. In the use case of CSV, Rados gateway fetches chunk after chunk. S3select engine processes each of these chunks, and the results are sent back immediately to upon completion. In this type of processing, a chunk may break a row in the middle, and the broken row are not processed, but are saved for the later and are saved and later merged with the next chunk. So to summarize, S3select engine processes row after row and send an immediate response with there are no preloading in this kind of processing. Okay, now I'm going to talk about the Parquet. So as mentioned before, Parquet is binary file, binary object. It is columnar object. By saying a columnar, it means that we can access directly a specific column without scanning or reading any other column, which is a user advantage. This type of object contains a lot of metadata. It enables the reader, as I said, to skip non-necessary information. At first, the engine verifies magic bytes to make sure it's a valid Parquet object. The next step, the engine fetches the predicate columns. In the case the predicate returns true, it fetches the projection columns and calculate the projection statement. For anyone who knows SQL statement, when I say predicate, I'm talking about the where clause, and when I say projection, I'm talking about the side of the select itself. Parquet object is structured. It contains schema. This unique columnar structure enables to skip data, as mentioned before, and eventually save a lot of IOPS. As for the main difference between the Parquet reader and the CSV reader, upon CSV flow, the Rados gateway fetches chunk after chunk and processes each separately. The Rados gateway controls the start and the end of the process. In the case of Parquet, the engine itself, the S3select engine itself, issue a read range request, and the engine eventually the engine itself controls the start and the end of the process, contrary to the CSV flow. Okay, this is a bit weird slide, but here I'm trying to explain why the JSON reader is unique compared to other readers. Upon querying a JSON document, the S3select engine is focusing only on specific parts of the nested and complex JSON data, and not the whole JSON data. It actually, some parts it ignores and some parts are loaded into the engine itself. It's meaning that the statement itself has an impact in the way the reader is actually scanning, reading, and loading the document. The next slide, I will try to explain that. So you can see that in this slide that the SQL statement is focusing its processing on a specific parts of the document according to the form clause. The form clause defines the boundaries where to get the projection and the predicate column. So you can see that the form clause says there, it says there from root, glossary, gloss diff, gloss list, gloss entry, gloss def. This actually define the path where to look for a specific column for the select statement. And the next slide, you can see here, and in this statement, it's actually the same document, but in this statement, the SQL statement, the form clause actually define a different row boundaries compared to the previous one. So in this statement, the readers will load different parts of the documents compared to the previous example, as I mentioned before. So let's talk about the JSON reader and the JSON processing flow. The JSON reader is unique, as mentioned, and actually it is different from other readers. Similar to the CSV, the all objects must be scanned and read completely. It means that the reader's gateway fetches chunk after chunk. But in the JSON case, the JSON reader controls the flow. And this is because, as I said before, in the unique structure of the JSON, only the JSON reader know when to call to the SQL statement, and it can determine when all columns are read and loaded, and this is the time to call the SQL processing. Okay, until now we cover actually all the current supported different types of the JSON, the CSV, and the Parquet. Now we talked about how to scale it, and we need to recall that running SQL statement on a single execution context is very inefficient when talking about big data. We strive to make it, of course, much more scale, at least scale up. So the ability of processing data stream without preloading or read is essential for the processing huge amount of data. This is achieved by processing row after row. That's what we're doing with our different readers until the end of stream. Quite similar to the Linux pipe concept. Having that, S3select function consumes little memory. S3select is able to split the query processing, merge the results upon completion into a single result. This powerful feature is very powerful for the big data ecosystem. In the next slide, I will explain a bit more. Okay, in this slide, I'm trying to explain how the way to improve dramatically the processing of this huge amount of data. And this is done by splitting the data into non-overlap ranges. That is, the system should run the same query on non-overlap data ranges in parallel, of course, merge the result, and upon completion, return all of them to the client side as a single one. It should know that per data type, the data splitting flow is different. In the case of CSV, the object is split according to the object size and the row delimiter. In the case of Parquet, this unique columnar structure, it is already divided into logical groups, so it's quite easy. But with the JSON use case, it's much more complex. So one way to handle that is to getting the data reside on many objects and split the work according to the amount of objects. Okay, in this slide, it demonstrates how S3select engine is processing an aggregation query in parallel. In this case, this is 3 parallel runs. So you can see there is some kind of select segment which does a substring while using a mean and average and count aggregation functionality with some predicate where clause. So this SQL statement are run in parallel on different range of the data. Upon completion, the mid stage wait for all of these parallel runs to complete, and actually what it does, it make a very unique recompute of the results. So it can be merged to a final result and sent back to the client. Okay. Okay, the coming implementation. Single query on many objects. What is the advantage of that? Okay, until now we discussed the the processing of a single and huge size object. So the advantage of processing this huge size object using S3select is quite obvious, saving a lot of network and also CPU. But what if it needs to run a single query on many small and medium-sized objects? This may happen because the data is coming in small packages from several sources, or the data may spread on many buckets or directories. Think about time series processing. So this kind of feature allows you to perform queries without any size limitation, which is it's a big thing. And it should know that AWS S3select operates only on a single object. Okay, until now we saw quite a complex product, and the question is how to verify that the result of complex product with endless combination, such as S3select. So we have several utilities that we developed in our team, which mainly we're talking about generator of expression and statement. I will speak about several of them. One type of generator is a random arithmetic expression generator. It generates any kind of any type of arithmetic expression, and this expression can actually execute it on C compiler and also on S3select engine because it's the same syntax, and the result should be the same. So as you can see here, it's a very long and complex expression, and upon each of them is actually executed by the C compiler and also by the S3select engine, and the results are, of course, should be identical. Another method of verifying that this system is operating correctly is to use two SQL statements which are has a different syntax, but we know the semantic is the same. So if the semantic is the same, the result should be the same also. So for one example, in this you can see here two SQL statements. And they are very different. In this case, they are very different in the workloads. One is using a timestamp functionality, and the other one is using a string functionality. And still, they must return the same result for any random input. In that way, we actually can verify that these two statements operate correctly. Another example for that, you can see here, and the same thing. The syntax is very different, but the semantic is the same. So here you can see also these statements are completely different in the projection side and also in the predicate side, the workloads, and the abstract syntax tree and the execution flow that evolved from this statement is completely different. But still, the result should be the same for any random input. Okay, another type of generator is a query generator, an SQL generator. We developed something like that, a generator which can actually can generate an endless number of SQL statement, comply for our SQL parser, and to run them both on and run it this SQL statement on both on the Ceph engine and also on AWS engine, and of course the result should be identical. And this is also another system that helps us to find issues in the system. Okay, as for the future, there are several issues that we should be covered. one of the biggest challenges ahead of us is integration with Spark and Trino. Spark and Trino or Presto, for anyone who doesn't familiar with that, is a SQL analytic application, and such application may use the object storage as their backend storage. But as said, it is very inefficient use of storage, and that is because it needs to retrieve all objects participate in the query. But what if upon using S3select request instead of the get object request? This will improve the query performance dramatically. And S3select is actually you can think of S3select as an optimizer for this high-level application. It's need to understand that there is a great advantage using SQL analytic application since so many end-user applications are written for Spark and Trino or Presto. What is needed from this analytical application is to identify what parts of the query can be pushed down to S3 storage and send this part as a subquery as S3select request. And should bear in mind also that this type of optimizer already exists in AWS CMR. As mentioned before, the S3select can be used as a command line utility as any other shell command. So it can work on standard input or files reside on your local file system. You can review the GitHub repo of S3select and see that for yourself. I will give some examples for that. If you look on the first statement, you can see one second. The first SQL statement is actually running on the standard output of the PS command. Okay. And as you can see, you can actually define what is the column delimiter. In this case, it's blank, and also define that there is CSV header info. So what you can see here, since PS is printing out the name of each columns when you're doing PS. The first row is actually the name of the columns. We can use that in the select statement. You can see that we do select PID command from standard input, where parent PID equal 1 is so easy. You can do it from the command line. That's it. In the second example, you can see an SQL statement processed by container. I will explain about this container later. The input data is piped into the container itself. So again, this container is actually a container that lets you not just running S3select from the command line, but actually you can review the code, you can change the code, you can actually build it, rebuild it. This container also contains some build utilities, so it's quite easy to get some impression what is all about the S3select. And of course, you can run queries on it. And the last one, you can it's an example of SQL statement that processed by the container, also as the previous one. But this time, the input data is mapped to the container file system. So you actually, in this case, you can see that I'm running here a statement, SQL statement, on some file on the host machine. After mapping, of course, mapping the directory of the host machine to the container itself. And yeah, that's it. I would be glad to hear for any type of question if you have.